Hello. So in this video we'll see some examples of cascode current mirror, and we have seen the very basics theory about the cascode current mirror in the previous video. So let's see some few of the designs, that what can be possible if we can use that or not. So first is, if you see here, so we have M1 and the gate is connected here. So the requirement is this has to be VOV. So what we did, we have connected here, and this drop is VTH of M1. So this will become VOV1. So yes, this section can be used as a reference for the current generation. But the problem is, for cascoding, if you see here, we need to have generate VB here. Okay, so primary thing is here to look upon is that we have nmos, and this is connected here, and there is one resistance here. So this is, yes, we can use this as a reference for the cascode current mirror. Okay, let's go to the another circuit. So this is another circuit. So what we will see, we will replace this resistance into mos, and we will have to generate VB. Okay, so first problem here is we have to generate VB. We are not connecting somewhere inside this circuit. We are not connecting anywhere. We are just making it available, and we will generate some VB and we will connect here. Now what is the issue here is, this is okay, so this, if you see, this is VOV, overdrive voltage of 1, and this is the VTH. Then only this will become VGS, okay, of M1. So for this device to be work in saturation, we need to have this VTH should be greater than whatever the overdrive voltage of M4. So what is the overdrive of M4 is VGS minus VTH. Okay, so from here we can see that condition, and to think while designing, we should have this in our mind, that for M4, VTH of 1, that is M1 device, should be greater than the overdrive voltage of 4. What does it mean? It means that whatever VGS4 minus VTH4, this difference should be less. And how this difference should be less? By making this VGS and VTH closer. Okay, so this is only the way, that VGS4 should be nearer to VTH4. It should be greater, but it cannot be very high value. The VGS4 cannot be very high. If it is very high, then this difference will go up, and it will be greater than the VTH value. So this solution won't work. So yes, we can use this as a MOS cascode current mirror, but problem is we have to make this device in a saturation, and for that our condition is the threshold value of M1 should be greater than the overdrive voltage of the M4. Now let's see again another circuit. Can we use this as a current mirror reference circuit or not? Okay, so let's see here. So what we did, we have connected that node here. We are generating our VB itself here. We don't need another circuit to create the voltage here. We are making this as a diode connected, and this VB is generated here itself in the same circuit. We don't need the another circuit to create the VB. Okay, so let's see here. So this is overdrive voltage. This is the okay. Now if you see, this section was the resistance that we connected. So this is the VTH also. So from here we can see that since it is a diode connected, we have the VGS requirement of this device. VGS4 is equal to VTH1. Okay, then only it will work. So your M4, whatever this device is, the VGS value, whatever the gate source value between these two, that should be equal to the threshold voltage of the M1, then only it will work. So let's say if VTH1 is equal to VTH4, then VGS4 is equal to VTH1, then VTH4, so it will not work. It will work the on condition of the device is to be greater than VTH, but it will be just on, or we can say that near to sub threshold. Okay, so this is the condition here, that we can use this device, but problem is this device will be near to the sub threshold, or we can say that this VGS requirement is to be equal to the VTH1. Also we can change the flavor. Okay, if we change the flavor of M4, then what is the requirement? We see from the above circuit that this is the VGS4. VGS4 should be greater than VTH4 when it is complete in on stage, and VGS4 is equal to VTH1. In that case, if you see here, VTH4 yani it means that this device should be in low VT, flavor should be low VT device, then only it will work good, or it will be completely on. So yes, we can use this, but the problem is the VGS requirement is near to the threshold voltage. Okay, so there will be no margin available, or we can use that only in the condition where different flavor of the device will be used, and in that case upper MOS diode connected will be the low VT device. Okay, we can use this. Now let's go for the another circuit. Let's see if we can use it or not. So here what I did, I have added one more resistance here, such that in the previous circuit, if you see here, diode connected, I have made this diode connected including one resistance here. Why I made this? Because I want this VGS to be greater than the VTH. So let's see if it is working better way or not. So in this case, if you see, this is complete VGS1, and this is VOV1, so this will be VTH1. Okay, and by this M4 to be in saturation, what is the condition then? Then VDS4 should be greater than VDS of the minimum of the M4, and that is VGS4 minus VTH4, and this is equal to VTH1. So again the requirement is the threshold voltage of M1 should be greater than the whatever the overdrive voltage of this, required overdrive voltage of this. Also, if you see the drop across this device, this resistance is VGS4 minus VTH1. So yes, we can use this device as a this section as a current reference circuit, but condition is we have to make this VTH threshold of this lower M1, VTH of M1 should be greater than the overdrive voltage of M4. Okay, so this has to be maintained. So what does it mean? It means that the difference between VGS4 and VTH4 should be minimum, less. We cannot make VGS4 very high. What does it mean? We cannot make this voltage very high. We have to keep this voltage low, near to the threshold. Then only we can use this as a current reference circuit. Okay. What will happen if both the devices are in let's say what we will do, you make M1 and M4 identical, that is W by L same, threshold voltage same, Okay, then let's see what is the requirement, what can we use that circuit or not. So in that case, if you see, this is total VGS, this is overdrive, this is threshold of M1, and this is also the VGS1 because both VGS are same. Okay, in that case, if you see, this will be the overdrive voltage of M1. Okay, so let's see our condition of saturation here. So for M4 to be in saturation, this is the requirement, VDS should be greater than the overdrive voltage of this. And if you see, VDS4 is VTH1. Okay, from here. So if you see here, VTH1, same VGS4 is VGS1, VTH4 is VTH1. So here this condition is valid. This VTH1 is greater than the difference of VTH1 should be greater than the overdrive of M1. So this is valid only and only if the difference is low between the VGS and between the VGS and VTH. Okay, let's see one example that how what is the meaning of this, that if we can use this device as a current reference circuit, then what will happen. So resistance is connected between this terminal. Okay, so let's see. So there are two, if you can see here, there are two cases. So let's see, one case is when VGS is near to the VTH. Let's say VGS is 200, VTH is 100, VOV is 100. Then if you see here, this is connected to here, so this voltage is total 200, this is 100, this will be 100. Okay, and this voltage is also 200, so this complete from here to here is 200, this is 100, then this will be 100. So let's see condition of M4 to be saturated. This will be always M1 will be in saturation always, because we have made the device such that the VDS is equal to VOV, so it will be in saturation. In this case, the M4, the VDS is 100 and overdrive is 100, so it will be in edge of saturation. Okay, so here if you see, the VGS is equal to 200 millivolt and VTH is equal to 100 millivolt. So in this case, this will work as a reference circuit because both the MOS are in saturation region, and we can use this gate voltage as a reference and make this cascoding here and here. Okay, so we don't need VB generation circuit here in this case, when we have added one more resistance from this to this. Okay, let's see one more example. Here you see that VGS is 300 and VTH is 100, then VOV is 200. In that case, this is 200, this is 300, so this will be 100. Now if you see that this VDS is 100 and VOV is 200, so M4 is in linear region, this M4. Okay, so this circuit, which circuit? This circuit when your primary MOS means M1, sorry, this is M1 and this one. So this gate is connected here and this gate is connected here, and there is one resistance between two. This can be used as a current reference circuit, and we don't need the voltage generation circuit here requirement. There is no need to generate any voltage because it is diode connected, so there is no third circuit required to generate the VV voltage which is required in the previous cases. Okay, and here also we can use this okay, that was the case when both M4 and M1 are in same VTH, identical devices. Here also it is same. When non-identical case, let's say in non-identical case, the overdrive voltage of M4 should be less than the VTH of this. So this can also be used, only that we should satisfy the condition. And before that we see that simply this was the very basic Cascode current mirror reference circuit. We replace this with a MOSFET, and but here we needed VB voltage generate another circuit to generate VB, because this is not diode connected, the middle one, MOS. So what we did, we have connected diode connected in a form, and we checked, we see that for this block to work as a current reference circuit, both VGS VTH1 VTH4 should be same. Also the VGS4 should be equal to the gate source voltage should be equal to the threshold of this device. Okay, if it is satisfying this case, then it is fine. In this case when both the M4 and M1 are in a same flavor device, but if we have a flexibility to change the flavor of device, then M4 lower VT device will be better. Why? Because then a VGS1 is equal to VTH1 will be greater than the VTH4, so there will be some margin for the VGS available. But best thing is that there is no VB requirement here. So these are some example of the different current reference circuit to use. Okay, thank you.